Okay, what I'm going to do today is I'm going to do 3 examples of solving equations involving algebraic fractions, building up in difficulty, starting with a fairly simple one that is the type that you will have met before. So 3 over 2x plus 3 is equal to 4 over x minus 6. You know full well that what we do here is we multiply across that equal sign. So that we have, therefore, 3x minus 6 equals 4 into 2x plus 3. Expanding the brackets, 3x minus 18 equals 8x plus 12. It's a nice linear equation, unknowns on both sides. We gather the x's together, we gather the numbers together. It makes sense to keep x as being positive, so it makes sense to subtract 3x from both sides, which gives us minus 18 equals 5x plus 12. Subtracting 12 from both sides, minus 30 equals 5x. Divide both sides by 5. We get minus 6 equals x. That's nothing new. If we look at the second equation, it is slightly different, and there are 2 ways that some of you may have heard of doing it. I will show you the quickest way, and then I will show you the way that realistically will mean that you won't make a mistake that I've seen far too often. Because people look at it, and because we multiply across the equal sign, quite often they think to themselves, I'll multiply across the equal sign. So I've got 5x equals 6 minus x. But remember, when you're multiplying across the equal sign, like we did up here, what you're really doing is multiplying both sides by x minus 6. It so happens that that will cancel out. And you're multiplying both sides by 2x plus 3. It just so happens that on this side, it will cancel out. So we've got to think that I'm actually multiplying both sides by x here. That has to give me an x squared. And I guarantee in every class there are a number of people who will make that mistake and will miss off that x squared. If you are worried that you are one of them, you can add in an extra line here, because what you can say to yourself is I'm going to make that all one algebraic fraction first. So I'm going to say that I've got 5 is equal to all one fraction, denominator of x. That's been multiplied by 1. That's been multiplied by 1. So I've got 6 minus. That's the same thing as having x over 1. So I've multiplied the denominator by 1. I've got to multiply by x, sorry. So I've got to multiply the numerator by x. So it gives me that x squared. At which point, you can multiply across. Okay. So now it's a quadratic equation. I have to make it equal to 0. I'm going to bring all these 2 terms onto the left-hand side because that will keep the x squared term positive. So I've got x squared plus 5x minus 6 equals 0. Now sorry, that doesn't look like minus 6. When I factorise it, I've deliberately chosen this one, because when you factorise it, I would guarantee that we're going to have a few people who put a 2 and a 3 in there, but we shouldn't have. Think about the signs. It needs to multiply to give us minus 6 and add to give us plus 5. It therefore has to be x plus 6, x minus 1. So therefore either x plus 6 equals 0, or x minus 1 equals 0, which gives us x equals minus 6, or x equals 1. Your biggest stumbling block there is that x squared. So you may well want to think to yourself, always get it written as an algebraic fraction before you start doing any form of multiplying. Looking at the next example, it is actually far easier really to write it as a single algebraic fraction. You could say I'm going to multiply everything by x minus 1 and then I'm going to multiply everything by x plus 1. However, I personally wouldn't. I would say that what I want is I want a denominator of x minus 1, x plus 1. And I would say to myself, right, I've multiplied that by x plus 1. So I have to multiply that by x plus 1, which is 3 times x plus 1 plus, I've multiplied this by x minus 1. So I have to multiply the top by x minus 1. And it gives me 3 times x minus 1. When I expand the brackets, at this point you have to be very careful if you've got a negative sign there, same as you did when we were subtracting algebraic fractions. You've just got to bring everything that we were doing previously to play when you're doing this one. So we've got 3x plus 3 plus 3x minus 3 over x minus 1, x plus 1 equals 4. But in all honesty, I didn't need to write that denominator there because I had that single algebraic fraction here. So I could have multiplied across and I could have straight away written this line, x plus 3 plus 3x minus 3 equals 4 into x minus 1, x plus 1, and that just fits. So if I do that, I then need to expand this bracket over here. And I've got 6x, the 3's will cancel out, into 4 times by x squared minus 1. We've got a difference of 2 squares there, remember. That gives me 6x equals 4x squared minus 4. It's a quadratic equation, so therefore we have to make it equal 0. So 0 equals 4x squared minus 6x minus 4. What I've got there is I've got a common factor of 2, so I can actually, because 2 is a number, I'm allowed to divide the whole thing by 2, which will make it easier when I'm factorising. So I've got 2x squared minus 3x minus 2. Remember, you can never, ever, ever divide by an unknown, though. It must be a known number that exists, because otherwise you're potentially dividing by 0, which doesn't exist. So if we then factorise that, we've got 0 equals 2x and x minus 2 and plus 1. So that gives me either 2x plus 1 equals 0 or x minus 2 equals 0, which gives me, if you rearrange it, it's going to give me x equals minus a half, or x equals 2. Okay, there is not really anything new there. It's just putting lots and lots of information and things that you've done previously together.